Hi, welcome back to Ken with Go. Today we'll take a look at the explanation of the Heisenberg uncertainty principle. Now, understand that when we deal with subatomic particles, they sort of behave a little differently than what we would normally be able to observe on a daily basis. For example, let me go ahead and just draw something real quick. Let's say we got a box that's sitting on a table. Okay. Now, in order for us to see this box, light has to bounce off of it. Now, when light bulb right here, okay, is shining, it has to shine the light on the box, and once it shines the light on the box, that light bounces off of the box and into our eyes. And I realize that my drawing is a little bit poor, but you get the picture. In order for us to see the box, the light has to bounce off of the box and then come into our eyes, and then our eyes are able to identify, oh, that's a box that's sitting on a table. Now, if this happened to be completely dark in the room, we wouldn't be able to see the box because there's no light shining on it. And if, again, we are in a completely darkened room with no light present, we wouldn't be able to see the box. And the reason why is because there's no light that's actually shining on there. Now, understand that light is energy. And light has this dual nature of being a particle and a wave at the same time. Now, when we take a look at these little tiny particles called electrons, they're negatively charged, light can come into here and actually excite the electrons. So if we had a light bulb, okay, shining, light has to bounce off of this, and then when light bounces off of that, it goes into our eyes. Okay, and that's how, technically, what we're just how we're going to be able to see the electron. The problem is that light also behaves like a particle. Okay, let me go ahead and erase this real quick. Light behaves like a particle. We call these photons. And when these photons come over here to hit these electrons, the problem is now the electron actually moves and changes position. So by the time the light bounces off of this and comes into our eyes, the electron will probably not be at that location. It might be over here. And that's kind of the strange thing, is because if we try to grab, okay, if we stick our hand in here, okay, to try to grab that electron to see if it's still there, it won't be there because the light actually pushed it out of place. And that's what Heisenberg is trying to state. He's saying that it's impossible to know the velocity, okay, and the position of an electron or any one of these subatomic particles at any given point in time, because the light itself, in order for us to see it, actually pushes that object out of the way. Okay, again, the Heisenberg uncertainty principle states that it is impossible to know the position and the velocity of any one of these subatomic particles at any given point in time because of the fact that these particles of light, these photons, when they run into these subatomic particles, they actually change its position and change its velocity. So the weird behavior of these particles, okay, is sort of described by Heisenberg. Okay, and it's kind of a strange thing when we get into these subatomic world. Things sort of behave a little bit differently and it's really sort of difficult for us to be able to observe these particles because in the process of observing it, we actually change the position of these particles. All right, and that's the short, sort of brief explanation of the Heisenberg uncertainty principle. And I'll see you in the next lecture.